Kindly draw Werner structure for this compound. We have COCl3.6H .6NH3. So the first thing to do is central metal atom, which is cobalt, right? And then how many ammonium we have? We have 6 ammonium, right? So then you draw 6 lines, straight lines. Do you understand this? We draw, then you occupy these lines with your ammonia. So we have 6 ammonia now. Then we have 3 chlorine. So remember, ammonia, it satisfies the secondary valency, right? And secondary valency is represented by normal lines, right? So that's why all these 6 ammonium are being distributed along these secondary valencies, which are represented by lines. Then chlorine is a negative, right? Is a negative ion once into solution. So therefore, they satisfy the primary valency of the central metal atom, right? So therefore, they are going to be distributed along the dotted lines, which represent the primary valency. So then the second thing to do is to identify which among these will go into solution. So the easiest way to do so is to react it with silver nitrate. So after reacting this with silver nitrate, 3 moles of silver chloride will form. Why? Because as we can see, all these chlorines, they are along these dotted lines. They are all along these dotted lines, which means we recall that primary valency can go into aqueous solution, right? So once they go into aqueous solution, they are going to what? They are going to react with the compound inside that aqueous solution. In this case, is silver nitrate, and they form 3 moles of AgCl. Do you understand this? Yes. So the structure will be like this. Since all these 3 chlorines have gone into solution, then you draw your coordination sphere, your cobalt, then the ligand should be here. How many ligand we have? We have 6, right? We have 6 ammonia, so therefore you have your 6 ammonia. Then outside the coordination sphere will be your counter ion. How many? 3 chlorines. Do you understand? Yes. Any question? No. It is very simple, right? Then let us reduce the number of ligands now. Here we have how many ligands? We have 6 ligands, right? 6 ammonia. So now let us reduce it to 5 and see what are we going to get. Now, having reduced the NH3 to 5, then we are going to distribute it along the secondary valency, which is represented or denoted by lines, right? These lines you see, they are secondary. So however, in this case, this one chlorine, since we have deficiency of one nitrogen, then it has to act as both, it has to satisfy both the primary valency and secondary valency. So that's why you see it has normal line and dotted lines. Do you understand this? So in this case, it means it is directly attached to the to the cobalt. So once this is react with silver nitrate, then we see that 2 moles of silver chloride are formed. Why? Because as we see, only two chlorines can go into or can dissolve in aqueous solution and go into reaction. Do you understand this? So therefore, to write this structure, then since this is already inside the coordination sphere, because it is directly attached to the central metal atom, then you are going to write your coordination sphere, your central metal atom, the 5 nitrogen, right? 5 nitrogen and then 1 chlorine inside. Then how many will be outside? 2 moles, right? Then 2 chlorine outside. Do you understand this? Yes. So now let us reduce further this ammonia into 4 and see what are we going to get. So now having reduced this ammonia into 4, we have our central atom, right? So then we are going to have 4 ammonium, right? 4 ammonia. So now this 4 ammonia, now we can see among the chlorines, 2 has to satisfy both the secondary and primary valencies. Do you understand this? Then they are now direct to the what? To the central atom. Then they cannot go into aqueous solution. Do you understand this? So therefore only 1 chlorine is left. So once this structure or once this coordination compound is reacted with silver nitrate, then only this will react with this silver, right, to form 1 mole of silver chloride. Do you understand this? So therefore the structure will be what? Now we have 2 chlorine already inside the coordination sphere, right? So we are going to have coordination sphere, cobalt, 4 ammonia, right, and then 2 chlorine, then 1 chlorine outside, which is the counter ion. Do you understand this? Any atom or molecule which is outside the coordination sphere is said to be a counter ion. Do you understand this? Whether it is negative or positive counter ion. So next, let us reduce this into 3 and see. So now we have 3 ammonium, 3 ammonia. NH3 is ammonia, NH4 plus is ammonium. Now, so we have this cobalt, right? We have 3 ammonia. So then all the 3 chlorine now have to satisfy both the primary and secondary valencies. So once such happen in such a situation, once this compound is reacted with silver nitrate, there will be no reaction because there is no any chlorine or any other element that is outside the coordination sphere. So they cannot go into aqueous solution and participate in what? In chemical reaction. So therefore there will be no reaction. So in this case, all this nitrogen and chlorine will be inside what? The coordination sphere. So we have 3 NH3 and we have 3 chlorine. Do you understand? Yes. Any question? No. I wish you all the best. So now let us see what we have next. Ligands.